Okay, let's see if I can keep this explanation short and sweet. This is the practice test for Unit 8 that's coming up. Don't forget to also practice on the review on problems number 5, 6, 7, 8, and also number 10 through 11. So on the review, I'm going to go ahead and write it on here. On the review, you should also do numbers 5 through 8, and then also number 10 and number 11, because there will be problems like that on the test. I did go over those in class today, so I'm not going to worry about that. Okay, so on the practice test, I went ahead and worked them all out so I can kind of rush through the video a little bit, and you can go back and look at the ones that you're concerned about. And fast forward me, pause me, whatever you need to do. So it's find the value of x find the values, so it could be more than one, of x that make the inequality true. Show the work that leads to your answer. You will be provided with just a blank number line on your test, just to kind of remind you need to do your test areas, okay? So the first thing you want to do is start off by factoring what you have, the numerator and the denominator. So I factored the x squared minus x minus 56 by saying what multiplies to negative 56 that adds to negative 1. So you have a negative 8 and positive 7. Because if you multiply, that is negative 56, and then negative 8 plus 7 is the negative 1. So those are my factors of the numerator. On the denominator, I can take a 5x out of both terms. So when I divide 5x squared by 5x, I'm left with x. When I divide 5x by 5x, I'm just left with 1. A lot of students might make the mistake of making that 0. But remember, if you had 5 over 5, that would be equal to 1. It would not be equal to 0. So we do have a 1 left there. Okay, so we want to check to see what our critical values are for here for doing our number line. So we have one at 8 and we have one at negative 7. Sorry guys, here's positive 8 here that I used, and then here's my negative 7. And then also from the denominator, I have some things that x cannot equal, which are our 0 here and our negative 1. And we want to test the values in between those numbers and beyond those numbers. So I chose in blue here, I chose to the left of negative 7, I'm going to use negative 8. Between negative 1 and negative 7, I chose negative 2. Between negative 1 and 0, there's not a lot in between there, so I chose negative 1/2. And then between 0 and 8, I chose to do positive 1. And then beyond 8, I chose positive 9. And so I showed the work over here. Remember, you are doing this without a calculator on the test. And what you're really only looking for is whether it's positive or negative. I don't really care what the number itself is. So you're just plugging the values in, those numbers that I chose to try. You're plugging them into the original equation. And so I showed my work for you here. And so when I'm plugging in negative 8, this is going to be a positive 64, minus a negative is going to become plus 8. So I have 64 plus 8 minus 56. 64 and 8 added together are going to be bigger than minus 50, or bigger than 56. So my top is going to end up being positive. I don't necessarily need to know that it's 16. I just need to know that it comes out positive. When I plug in negative 8 to the bottom, negative 8 squared is 64. 64 times 5 is going to be a really big number. And then 5 minus 8 is going to be negative 40. So you're going to have this really big number. And subtracting 40 from it is obviously going to be positive as well. So when you do a positive divided by a positive, you're going to have a positive in that area. So this little section, anything to the left of negative 7 is going to be positive. When I plug in, when I plug in negative 2, I'm doing negative 2 squared minus negative 2 minus 56 on the top. Okay, and when I do that, I get a negative 50. Again, you don't need to know that it's negative 50. You just need to know that it's negative. So you have 4 plus 4 is 8. 8 minus 56 is obviously going to give you a negative answer. When I plug in negative 2 to the bottom, I'm doing 5 times negative 2 squared plus 5 times negative 2, which I'm showing here. And so negative 2 squared is going to be positive 4. 5 times positive 4 is 20. And so you're going to have 20 minus 10, which is obviously positive. When you take a negative and you divide it by a positive, there are different signs. So you're going to end up with a negative answer. So anything between negative 7 and negative 1 is going to be negative. So you can look at the work I showed here for you. plugging in -1/2, plugging in 1, and then plugging in 9. When I plugged in -1/2, I had a negative divided by negative, which is positive. When I plugged in 1, I got a negative divided by positive, which gives you a negative. And then plugging in +9, you get a positive divided by positive, which is positive. So I have marked those here underneath the underline, the number line, excuse me. We want a negative. So anywhere there's a negative, that's part of our solution. So that's going to be from -7 to -1, and also from 0 to 8. We have to be really careful though, whether we use brackets or parentheses. This does have the bar underneath it, which means it's equal to, but it can only be equal to 8 or -7. We are undefined at 0 and -1. So we want to put parentheses on these numbers if they're in our answer, in our solution at all. So bracket on -7, bracket on 8, parenthesis on -1, parenthesis on 0. And when we have two different sets of possible intervals, we put a U in between to represent or. That's the symbol for union. So we're saying it's this set of numbers or this set of numbers satisfies this equation. Okay, that is the longest question on the test. I promise you will spend quite a bit of time on that one, just calculating all these values to get the signs right. It takes some time, so just get through that one and then it'll go a lot faster from there. Okay, number 2 on the practice test, give a sketch of the polynomial. First thing I'm going to look at is what's my end behavior going to do? So this is a negative, and the highest exponent is 7. So that makes it a negative odd function. If it's negative odd, then I know it's going to be going up on the left and it's going down on the right. That's going to be my end behavior. From there, I want to factor anything I can, break it down to its most basic factors. So we're going to take out a negative x to the 5th power out of each term. And so then I want to see what's left over. So I factored out negative x to the 5th. So here I'm left with x squared. Here it changes the sign because I am factoring out a negative. And so that's going to leave me with plus 24x. Here it's going to leave me with plus 143. The x to the 5th completely cancels out because I took x to the 5th out. And the negative became positive since I took a negative out of everything. From there, we're going to say what multiplies to 143 that adds to 24. You might have to try some different possibilities, and this is on the non-calculator part. So you might have to write down some numbers that multiply to 143. But what works is 13 times 11 is 143. 13 plus 11 is 24. So that factors down to x plus 13 and x plus 11. And so this gives us a lot of information here. We have x equals 0 from the negative x to the 5th. And that has multiplicity of 5. So if you have an odd number multiplicity besides 1, if you have a multiplicity of 1, it just passes through that point. But if you have 3 or 5 or 7 or 9, that's going to cause a bend in your graph, okay? So since we have multiplicity 5, at 0, we should see a bend. Okay, we have a single multiplicity at negative 13 and then a single multiplicity at negative 11. So it's just passing through those points. So remember our end behavior. So at negative 13, it's going to be going up on the left. At the 0 here, it's going to be going down on the right because of our end behavior. It's bending through 0 and it's passing through both negative 13 and negative 11. So that's how I came up with that graph. Number 3, find the coordinates of the hole in the graph of G. You want to start off by factoring everything. So the top is going to factor. We're saying what multiplies to negative 20, that adds to positive 1. So that gives me 5 and negative 4. Okay, so x plus 5, x minus 4. And then on the bottom, this is a difference of perfect squares. So that's going to factor to x plus 4, x minus 4. You're going to have a hole when you have factors that match. So I have a hole at x equals 4. Because if I take x minus 4, set it equal to 0, that gives me x equals 4. So once I know that, in order to find the y coordinate of my hole, I'm going to kind of just ignore these x minus 4s, and I want to plug in the 4 to what's left over. So I want to do 4 plus 5 divided by 4 plus 4, which I did here for you. So that gives you 9/8. So we have a coordinate at 4, 9/8. That's where our hole is at. Okay, on to the second page. Give a sketch of each function. You must plot and label all intercepts, asymptotes, and holes if they exist. And we are going to give you a space on the test, I believe, for you to just go ahead and list this information so you don't forget to do that. First thing you want to do is you want to factor out any pieces you have. So I factored out the 2x squared minus x minus 6. Let's see if I kept my scratch paper here. I did the x method, which you guys seem to like the best, class-wise. So the 2 times the negative 6 gives you the negative 12. You have a negative 1 as your middle term. And so you're saying what multiplies to negative 12 that adds to negative 1. And so that would be negative 4 and positive 3. So what you did from what you guys usually do from there is you break this into these negative 4, this negative 4 and positive 3x. Okay, so you have your 2x squared comes down. This breaks into negative 4x plus 3x, and then you brought your negative 6 down. Okay, and then we factor by grouping from there. So 2x can come out of both of these terms. You're left with an x minus 2. 3 can come out of both of these terms, and you're left with an x minus 2. So x minus 2 can factor out, and it's here, and then you're left with 2x plus 3. So this factors down to x minus 2 times 2x plus 3, which I have written here, except just in backwards order. So right away, I can see that I do have a hole at x equals positive 2. So we'll deal with that in a second. But let's talk about the x-intercept for a second. Since this is a hole, that's not going to be an x-intercept, but this part is going to give us the x-intercept. So whatever the top, you want to set that equal to 0. Make sure it's not a hole, but anything that's left over on the top set equal to 0 gives you your x-intercept. So if I subtract 3 to the other side, that makes it negative 3, divide by 2, and so that's where I got the x equals negative 3 halves. When I go in to do my y-intercept, I want to plug in 0 for all the x's, back to the original. So I'm going to go 0 here, 0 here, 0 here. So really, I'm just going to be left with negative 6 over negative 2. Negative 6 divided by negative 2 is positive 3. So that's my y-intercept of positive 3. I already said we have a hole at x equals 2. Remember that whatever's left over, when you cancel out those factors that made the hole, you want to plug the x equals 2 whatever's left over back into that. So we're going to go 2 times 2, is 4. 4 plus 3 is 7. So that's going to be 2 comma 7 is where the hole is at. Let's see, vertical asymptotes, that's wherever the bottom does not equal 0. Like we cannot have the bottom be 0, so you want to set that equal to 0 and solve. The problem is this is already a hole, so that means it's not a vertical asymptote. So there's nothing left on the bottom to be undefined. And so that one's just going to be none this time. We'll see some other examples where we do have a vertical asymptote, but this one, you would have it at x equals 2, but since it's a hole, it's not actually a vertical asymptote. And then we go to the horizontal asymptote. That's where we check the Bobbio-Botno eats TC. Okay, so you want to look at your highest degree on the, highest term is 2 for the exponent. On the bottom, it's 1. So you're bigger on top than you are on the bottom. So that's Botno, bigger on top. And so that means there's no or none for the horizontal asymptote. Okay, so you want to graph negative 3 halves on the x-axis, positive 3 on the y-axis. You want to graph your hole at 2, 7, and make sure you leave it as an open dot, okay, because it cannot equal that. We have no vertical asymptote, we have a horizontal asymptote. You can plug in points here to see what it's doing, but hopefully we've done enough practicing, and you've seen through practicing on your homework that when you cancel that hole out, it leaves you with the equation of your line. Okay, so you have a line at 2x plus 3. So you would have from the y-intercept to 3, you would go up 2 and over 1, up 2 and over 1. Oh, we hit the hole, and you can continue that on. And that is going to create your entire line of a slope of 2 and a y-intercept of positive 3. Okay, number 5. Let's see, where did I start here? I started by just factoring. I like everything factored out, and that just right away lets me see if I have any holes or anything like that. And so I factored, this is the difference of perfect squares, so it factors to x plus 3, x minus 3. Nothing can factor on the top, it's good to go. So I don't have any holes. I can see that right away because none of my factors match. Excuse me. So let's go x-intercept. X-intercept is when you set the top equal to 0. So x plus 9 equals 0. Move the 9 over, you get -9. The y-intercept is when you plug in 0 for all of your x's. So you have 0 plus 9 divided by 0 squared minus 9. So you end up with 9 divided by -9, which is -1. We already said there's no hole because none of our factors for top and bottom matched. You do have a vertical asymptote. You actually have 2 of them. On where the bottom would be equal to 0. So this one gives you x equals -3 as a vertical asymptote. This one gives you x equals +3 as a vertical asymptote. We got to check Bobio-Botno eats DC for our horizontal asymptote. So we have a exponent, the highest one is 1. On the denominator here, the highest exponent is 2. So the highest exponent is going to be on the bottom. So we have bigger on bottom, y equals 0. So we have a horizontal asymptote at y equals 0. So we need to graph these things. So we go, let's see, -9 on the x-axis, put a point, -1 on the y-axis, put a point. There's not a hole, don't worry about it. Vertical asymptote at -3, make sure it's a dashed line. Vertical asymptote at +3, again, make sure it's a dashed line. And then horizontal, y equals 0 is the x-axis. You want to put your dashed line. We do want to see all asymptotes graphed on your graphs as well. Don't leave those off, but we do want to graph them with dotted or dashed lines, not solid lines. Okay, and so from there, you'll see what I did in blue here, and you're just going to have to do it, folks. I'm not going to talk you through every little step, but I have my -9, I have my -3, I have my 0, +3, and you want to check in between there. Is it above or below the axis? So you want to test points. So these points on the bottom came from those critical values that you see here, okay? And you see them in the graph. But I made these up, the -10, -4, -1, 1, and 4. Those are kind of negotiable. You could have picked something else, but I made them up for where they're at in the gap, in the different gaps. So to the left of -9, I chose -10. I plugged it in to the original equation and found out that it gave me a negative. And I don't care what the value is, I just know it's a negative number. When I plugged in -4, I got something that was positive. When I plugged in -1, I got something that was negative. +1 gave me something negative. And then plugging in +4 also gave me a positive. So that just tells me, is my curve above or below that asymptote? It has to go through the x-intercept here, but when we plugged in, or when I plugged in -10, I did get negative, so I knew it went below the asymptote there. But when I plugged in -4, let's see, 1, 2, 3, -4, it gave me a positive value. So that told me this curve was going to shoot up there. Okay, when I plugged in -1, I did see that I got a negative answer. And then when I plugged in +1, I got a negative answer as well. I've got to go through this y-intercept. So it's going to be this nice little downward parabola there. And then when I plugged in +4, I got a positive, so then I know it's above the asymptote there. And on to number 6, to see what I did there. So factored out the top to get 3 times x minus 4. That's going to show me that there is no hole on this one. So we're going to have hole is none. Let's see. Plugging in, let's see, take the top and set it equal to 0. Because I'm looking for the x-intercept, so move the 12 over, makes it positive, divide both sides by 3, so you get x equals 4 for the x-intercept, okay? And then y-intercept, we're plugging in 0 everywhere there's an x, so 3 times 0 minus 12 divided by 0 plus 2, you're going to end up with -12 divided by 2, which is -6. So x-axis, we're going to have a dot at 4, y-axis, we're going to have a dot at -6. We already said there's no hole since no factors matched. For the vertical asymptote, we're going to set the bottom equal to 0. So x plus 2 cannot be 0. Move the 2 over. So at x equals -2, you're going to have an asymptote. And then horizontal asymptote, we're going to look for Bobio-Botno eats DC. And we have a degree of 1 and a degree of 1. So they are the same. This is, what does this stand for? Eats DC. I know it's equal, something about the degree. I'm going to move on. But I do remember that DC is divide coefficients. So if they're equal, if your degree is equal, your exponents, then I think it stands for exponents are the same. It's coming back. Exponents are the same. Then you divide coefficients, and that's the leading coefficients, okay? So if they're equal, divide coefficients. So that's going to be 3 divided by 1, and so that's why it's y equals 3. Because our leading coefficient on the top is 3, our leading coefficient on the bottom is 1. Okay, sorry, exponents are the same. I think that's what that stands for. I just lost that for a second. Okay, back to this though. So we have all these values we can graph now. I always start personally, I already talked about graphing the x-intercept and the y-intercept. There's not a hole, then I go to the asymptote. So vertical asymptote at x equals -2, horizontal asymptote at y equals 3. Then you've got to try some values. So we already have some critical things we know. We know there's something going on at -2, that's the asymptote. We have a y-intercept at 0, at where x equals 0. We have, let's see, why did I pick 4? That's because that's my x-intercept. So let me check what's going on around those critical places. So for -2, I picked to the left of it -3. So when I plugged it into the original equation, I have something positive. So then I know that it's going to be above this horizontal asymptote, and it's going to be bounded by these two asymptotes. So it's in there somewhere. That might not be hitting the exact point, but get the curve in between there. And then when I went between 0 and -2, I chose -1 to try. And when I plugged in -1 to my original equation, I got something that was a negative. So I knew from this y-intercept that it was going to be going down. It's going to be negative. It's not shooting back up. Okay. When I tried between 0 and 4, I chose to choose 1. When I plugged in 1, I got a negative answer. So I plugged in +1 up here and got something that was negative. And so I knew it was still below the x-axis. When I plugged in 5, it did get positive. And so that shows me that it's going to come up. Okay. And number 7, 8, and 9. Let's see. Analyze the following function. We're using the same function for 7, 8, and 9. It says, what are the equations of the vertical asymptotes, if any? Remember, that is where the bottom is equal to 0 as long as it's not a hole. And so you do need to factor the bottom. You're saying what multiplies to -4 that adds to -3. So that would be -4 and +1. So you have x minus 4 and x plus 1. The deal is, though, that x minus 4, that's actually a hole. It's not a vertical asymptote. So that's why you see that x equals 4 over here. But if we didn't know that yet, if we weren't to the whole part yet, then we might think that both of those are giving us a vertical asymptote. So we would say x minus 4 not equal to 0 and x plus 1 not equal to 0. And we would solve that. And so we have a vertical asymptote at -1. We know there's not really one at 4, so we're going to call that a hole, so we're going to X that out. And even if you show that work, you would want to not box it or X it out to show it's not a solution. Because we know it's a hole. And so x equals 4. They're going to want the entire coordinate, not just the 4 that you're getting from the matching factors over here. And so what do you do to find the y coordinate? You cancel out what gave you the hole, and you see what's left over. If there's nothing left on the top, it's not 0, guys, it's a 1, okay? So we're left over with 1 over x plus 1, and we want to plug that 4 in everywhere there's an x. So we're going to do 1 over 4 plus 1, so it's going to be 1/5. So that's the coordinate, and that's your y coordinate of your hole, so it's going to be 4, 1/5. And then it says, which x values have discontinuities, if any? So remember, that's where you have to pick up your pencil. That's going to happen at any hole. That's also going to happen at any vertical asymptote. And so you just want to list both of them. So what x values? So that would just be -1 and +4. Okay, one more page. Here we go. On number 10, it says, find the equation of the horizontal asymptote to the graph of G if it exists. If they want horizontal, you need to think Babio-Botno eats DC. Vertical asymptote, we set the denominator equal to 0 when we solve it, making sure there's no holes. But for horizontal asymptote, we just Babio-Botno eats DC. This one is a little complicated. We're going to need to know what the highest term would be if we like multiplied this all out. So if you like foiled this and all that, but you don't have to go that far. You just need the first term. So if we distributed this in here, we would have 4x to the 4th power plus 7x cubed. But I don't really care about the 7x cubed. I only care about the 4x to the 4th power. So I'm going to keep that in mind. On the bottom, you would have to cube this out. So you're talking 2x plus 5 times 2x plus 5 times 2x plus 5. I don't have to do all that. I just have to know that 2x times 2x times 2x is going to give me 8x cubed, because you're going to be multiplying that 2x times itself the 3 times. So that's 8x cubed, and then you still have the x here that you're going to have to multiply in. And so 8 times 8x cubed is 8x to the 4th. So these are the same exponent, so that's exponents are the same. I'm forgetting again. So divide coefficients. Exponents are the same, so divide coefficients. That would be 4 over 8 are going to be your leading coefficients here. And so 4/8 is 1/2. And so I said my answer is y equals 1/2. Remember that horizontal asymptotes are always going to be y equals a number. Vertical asymptotes are always going to be x equals a number. Okay, number 11, find the zeros of the function x plus 5 divided by x plus 2. To find the zeros, you want to just set the numerator equal to 0. Make sure it's not a whole. Okay, always checking if things are wholes. But these do not match, so it's not a whole. So we just say x plus 5 equals 0 and solve it. So x equals -5 would be a 0 for this, would be the 0 for that function. Okay, number 12, find the y-intercept. Remember that y-intercept, you let x be 0. So everywhere you see an x in here, you're plugging in 0. So I'm doing 0 minus 3 cubed times 0 minus 1 divided by 0 minus 2 squared. 0 minus 3 is -3. -3 to the 3rd power is -27. 0 minus 1 is -1. 0 minus 2 is -2. -2 to the 2nd power is +4. We have a -27 times a -1. That makes that a +27. +27 divided by just 4, sorry, is a +27 So it's not pretty, but our y-intercept is 27 Okay, find the, let's see, where am I at? I'm on number 13. Find the vertical asymptotes of that. Vertical asymptote is when the bottom is equal to 0, but make sure it's not a whole. So really it's just going to be both of these, because none of the factors are going to match with the top, so you don't have a whole to worry about. So this one gives you x equals 9. This one gives you x equals 2 with multiplicity 2. Multiplicity doesn't matter when we're talking about asymptotes. It's like, oh, you can't be this line twice. Who cares? Okay, so it's not worrying, about balancing or anything like that right now at this point. So it's just 9 and 2. Write the equation of the oblique asymptote to the graph of this divided by this. We want to divide this. You can do long division, or you can do what I chose, which is synthetic division. So I have my 7, my 2, and my -4, and we're dividing by +2. So it's if you solved for x. So x equals 2. You bring down your first term, so 7 just comes down. 7 times 2 is 14. Then you add 2 plus 14 is 16. We want to multiply again, so 16 times 2 is 32. Then you want to add, you get 28. This gives us, like, this is 7x squared. This always comes down 1 term, or 1 degree, I should say. So if this exponent is 2, then you're going to start with an exponent of 1. So it's 7x plus 16. We get to ignore the remainder. So our oblique asymptote would be 7x plus 16. That would be the answer. You ignore the remainder. I should not see any plus 28 over x minus 2. We don't need to see that. Okay, notice we are now at the calculator part of the practice test. There's only 2 examples. I promise you there will be a few more examples on your test where you can use the calculator. But here we go. They tell us to take the equation x squared plus 4x squared minus 1 and use the calculator to determine the intervals on which f is increasing and on where it's decreasing. So the first thing I did is I went to y equals and I typed in the equation x squared plus 4x squared minus 1. I did a zoom 6, which takes you to your standard viewing window of a -10 by 10, -10 by 10. Okay, and so basically that's what it looks like. I didn't put my scale here, but I'll explain that in a second. So once I have the graph, a general idea of what it looks like, it's going to increase anytime it has a positive slope. So in these two spots, it's increasing, and then it's going to decrease anytime it has a negative slope. And we're only going off of the x values when we're describing increasing and decreasing, not the y values. But in order to figure out where it stops increasing, I need the relative extrema. So I need this maximum and I need this minimum. So on my calculator, once I see my graph, I'm going to do second trace. I'm going to go for the maximum first. So I'm going to go for number 4, and I'm going to go to the left of it, press enter, to the right of it, press enter again, and it's popping at the top and telling me that that x value is at negative 2.667. Okay, I wrote down the 8.481. That's fine. You could ignore it though, because when we describe increasing and decreasing, we're only going off the x value. Okay, so from negative infinity up to that negative 2.667, I have an increasing piece. Now I need to find out this minimum. So I'm going to second trace number 3 this time. I want to be, this is my minimum. I want to be to the left of it, and then I want to come around to the other side and be to the right of it. I'm pressing enter and then enter again, and it's blinking on the bottom. This is actually 0. I know it looks really crazy. It's like 0.000015, whatever. That's just 0. Okay, so we're going to call that the point 0, negative 1. So now I have both of those x values that I needed. So we're saying that it's increasing from negative infinity up to negative 2.667. Union with, it's going to pick up and increase again from 0 to positive infinity. Okay, for decreasing, it's this little piece in between. So it's decreasing from negative 2.667 to an x equal to 0. Okay, one more to look at. The graph of a polynomial p of x is shown below. Determine the minimum possible degree. Minimum. So we know there can be bigger ones. We want the smallest possible degree that you can give this function. And the sign, is it positive or negative, of its leading coefficient. So it's up and it's up. So right now, because of end behavior, the up tells me it's got to be positive and it's got to be an even function. You might want to remember all of them. So if you have up, it's positive, even. If it's down, then you know it's still even, but now it's negative. Okay, if it's up on the right but down on the left, like a cubic function does, then that's going to be a positive odd. And if it flips on you, so it's up on the left but down on the right, then that's going to be a negative odd. So just make sure you know those. The end behavior comes into play several times here on the practice test. So make sure you remember those. But I know I'm looking for a positive even. So right now I know my leading coefficient is going to be positive. I need to look at the graph and say, okay, is it passing? Is it bending? Is it bouncing? So if it's passing through a point, then you're going to say it has multiplicity of 1. If it's bending through a point, then it could be, and I mean, you're going to see a bend like you see here, where it practically goes horizontal right there to go the other direction. Okay, so that could be 3, 5, 7, 9, any odd number. But if we want the minimum, we want the smallest possible number. So that's going to have to be a 3 to be the smallest possible. And then if it's even, that's going to cause a bounce. And what's our, I don't know why I put even, y'all, I'm sorry. If it's a bounce, so if we had something, it's going to hit it and then come right back out of it. That's what I mean by bounce. If we had that, then it's going to be an even exponent, and our smallest, most minimal is going to be 2. So remember those rules. So you need your end behavior, and then you need the pass, bend, and bounce rules. But anyway, both of these are bends, and so this one, lowest it could be is 3, lowest this one could be is 3, and so that would be 6. And that's the minimum it could be, and that is even. So that's how we know the minimum degree is 6, and then again, because of the end behavior, we know it's positive. That's all I have for you. I hope you study and do awesome on this test. Bye.